All right, coming at you from my couch. Here is your LT2 and 3 video. All right, how's that for an intro? Pretty sweet. LT2 is solve a linear equation. LT3 is justify each step in your solving of that linear equation. So it's things that you have definitely done before. Um, Now we are just practicing it a little bit, or remembering it and talking about why those little steps that you do, why those work, or why you can do that. So to kind of run over the steps in solving a equation, step one is eliminate the parentheses. In other words, this is the distributive property. Okay, so just as another example for you, we've seen this a few times, but to eliminate parentheses, draw in the little rainbows or the little arrows, and this becomes 3 times x plus, just copy down the plus, 3 times 4, which is 12. Okay, and again, we've seen that a lot of times, but whenever you are solving an equation, that is the very first thing that you're going to want to do. Step 2, add like terms on both sides, or combine like terms is another way that we have been talking about it, because we could also mean subtracting like terms. So that's going to be step 2 is combining like terms. In this case, our like terms are these x's right here. We got 2x plus a 3x makes for 5x. Copy down the plus 4 equals 20. So step 1, eliminate the parentheses. Step 2, combine the like terms on both sides. So we've combined our x variables over here. There are no x variables over here, so that step is done. Step 3 of solving an equation, make sure that the variable is only on one side. So if you look at this example, we have 6x plus 4 equals 2x, and we've got variables on the left side. We've also got variables on the right side. And so step 3 is make sure that we move them all to one side or the other. Typically, you're going to want to move them to the side that doesn't have the constant term on it. So in this case, we have a 4 as our constant here. So if we moved all the x's to this side, it wouldn't really do us that much good when we're solving it, because we would still have some x's plus 4 equals 0, and then we would have some more steps to do. So in order to avoid those extra steps, I always, just as a rule of thumb, move the x's, or the whatever variable, to the opposite side of where the constant is. So I'm going to subtract 6x, subtract 6x, and you are left with 4 equals negative 4x. Okay, so that's step 3. At this point, we have all the x's over here on the right side, and we have our constant over here on the left. And it would be very easy to finish solving from there. Step 4 is to eliminate the constant term, if there is one that needs to be eliminated. So in this case, we have the x's over here on the left side, and we've got a constant here, and then another constant over here on the right side. And similar to what I just said in step 3, you wouldn't want to move this constant over here, because then we would have 3x plus something equals 0, and that wouldn't help us solve it really. So we want to eliminate the constant that's on the same side as the variables. So in order to do that, I'm going to subtract 7 from both sides. And we know we can do that because of the subtraction property of equality, as long as I do it to both sides. And you get 3x equals 12. And from there, again, very easy to solve. You would just have one more step in solving that. And that last step, if you look on our last example, we ended at 3x equals 12. And so that very last step to finish solving 3x equals 12, this will either be the opposite of the multiplication or division. In this case, we have 3 times x, so we're going to divide by 3, and divide by 3. And since we divided by 3 on this side, we also have to divide by 3 on this side. because of the division property of equality. And those will cancel out, and we'll just have x equals 12 divided by 3, which is just 4. And then we've solved the equation. That's the last step. Okay. So what I'm going to do now is sort of transition from LT2 into LT3. So now I'm going to solve this equation using those steps, but I'm also going to provide justification for each step that I do. And those justification steps are going to be just like your properties of equality or distributive property. Okay. So if you go back to step 1 was eliminate parentheses. We don't have any parentheses, so that step is done. So we're on step 2, combine like terms on both sides. We don't have any like terms over here. We don't have any like terms over here. So we're on step 3. Make sure the variable is only on one side. So we have variables here, and we have variables here. So what I'm going to do is move them all to the left side. And to do that, to get rid of this negative 6x, I'm going to add 6x to that side. And if I add 6x to this side, I have to add 6x to this side. And from there I get 11x minus 6 equals, this all cancels out, and I just have 16. So 11x minus 6 equals 16. Okay. And the justification for that, why I can do this whole getting rid of this 6 thing, is that I added 6x to both sides, so that is the addition property of equality for your justification there. The next step would be to get rid of this minus 6 right here. So I would have to add 6 here, and then if I add 6 here, I also have to add 6 here. And exactly the same as what I just did, I added 6x, or I added just a constant 6. And since I did it to both sides, the reason I can do that is, again, the addition property of equality. So at this point, what I have is 11x equals, that all cancels out, 16 plus 6 is 22. So what I have left is 11x equals 22. And if you look back at our steps, I'm now at the step 5, eliminate the coefficient. So in the example we had 3x equals 12, now we have 11x equals 22. And so the way that I'm going to get rid of this 11x is by dividing by 11 and dividing by 11. And that leaves me over here with x equals 2. And the equation is solved, and the reason that I could do that, divide by 11 on both sides, is the division property of equality. Okay? So again, just steps that you already probably have at least seen or know how to do, but just putting a little bit more formal justification to it. Okay. In this next example, we do have parentheses, so the first thing I'm going to need to do is distributive property to eliminate the parentheses. So I'm just going to copy down the whole rest of this. 4x, and then this turns into a negative 8x. And be careful, because this is where some of you I saw were going wrong on LT1. If I have a minus 8 here, and then I'm going to take that and multiply it by 1, this is actually going to become a minus 8. Okay, because this negative comes with the 8 here over to the 1. And so I have actually a minus 8 here, not a plus 8. Okay, so that's a common mistake that a lot of people are making. All right. So I got rid of the parentheses, and of course the reason I could do that was the distributive property. Okay, so the next step is to combine like terms on both sides. And in this example, I have 4x's here and negative 8x's right there. So I'm going to combine those two together to make negative 4x, and then just copy down the rest. And the reason that I can do that is just combining like terms. Combining like terms is something we talked about in the LT1 video. My next step, I've got all the variables on the left side, but I've got this minus 8 here that I need to get rid of, so I'm going to add 8 to that side and add 8 to that side. That leaves me with a negative 4x. This all cancels out, equals 16. And you can probably guess, we've seen this one several times, that I added 8 to both sides, so that is the addition property of equality. And the very last step that I have to do is to divide by a negative 4 on that side and a negative 4 here. And the reason that I divide by a negative 4 is because the coefficient on this x is negative 4. Okay, dividing by a 4 that's positive 4 will result in a negative x here. So you have to divide by a whole, the full coefficient, which is negative 4. So dividing by negative 4 gives you x right here, and 16 divided by negative 4 is negative 4. And since I divided on both sides, the justification for that is the division property of equality. Okay. Now, there are a couple special cases that I just want to run through for you really quick. And I'm going to go ahead and solve these. I'm not going to give quite as much explanation as I did on the others. But this would be a good opportunity if you kind of want to test yourself a little bit. Go ahead and pause right now. And you can go through and simplify both the left side and the right side of this. And get it to a point where you think you might be able to solve it to check your steps. And then you can unpause and watch me do it if you want. If you don't feel comfortable doing that, you don't have to by any means. Okay? So here are my steps. So distributive property to eliminate the parentheses gives me 2x plus 8 minus 5 equals 2x plus 3. The next step then is to combine these. 2x plus 3 equals 2x plus 3. Now it starts to look a little weird here, but I'm just going to keep going. I'm going to get rid of this 3 right here, so I'm going to subtract 3 from both sides and get 2x equals 2x. And then I'm going to go ahead and division property of equality get x equals x. Okay. Now the reason that this is a special case is because we end up with this x equals x right here. And basically what that means, if you think about it, is that no matter what steps that I do to this, these two sides, the left and the right, will always be equal. No matter what steps you do to it, and no matter what you try and plug in for x. So if I put in like an x equals 2 right here, I will eventually get that this side equals the exact same as this side, which in that case would be 7. So if I put in x equals 2 in here, I will get 7 equals 7. If I put in x equals 1 in there, I will get 5 equals 5. Okay, so for no matter what value of x you put in here, you will always get the same on the left side as the right side. And so because of that, this has infinite solutions. So if you're solving an equation and you eventually get to a point where, like right here, or right here, or right here, they equal the exact same thing all the way down, that means that there are infinite solutions. There's infinite possibilities for things you could plug in for x that would make the two sides of this equation the same thing. Okay, so that's special case number 1. Special case number 2 is over here. So again, you can pause if you want, but here are my steps. So combining like terms, 4m minus m is 3m, plus 1 equals 3m plus 9. And you can kind of already start to notice that I've got a 3m over here and a 3m over here. So they're sort of starting to look like this a little bit, where it's starting to look the same. But there's a big major difference here, and that is that here I have a plus 1 and here I have a plus 9. So the big difference here is that if I were to go and maybe subtract 1 from both sides and get 3m equals 3m plus 8, and then maybe subtract a 3m here and here, I would get 0 equals 8. But 0 doesn't equal 8. Or, if I want to back it up a little bit, and maybe subtract 3m from both sides, I'll get 1 equals, that all will cancel out, and I'll get 9. Okay, but 1 doesn't equal 9. 1 is 1, and 9 is 9. So, because you eventually get to this point where all the variables are gone and you have something here that's just not true, those are not equal. Because those are not equal, this means that there are no solutions. And you'll have that sometimes, that if you think about trying to put in something for m, maybe try and plug some values in if you want. Put in a 1 here for m, or a 2, or a 10, or whatever you want to do. There is no way that you can put in the same thing for m on both sides and make this equal. Okay? So no solutions is the special case number 2. For your before class, and it's very, very important that you do this because your partner is going to be kind of counting on you having done this, is to write an equation that you are going to have your partner solve. And you need to make sure that your equation has a solution. So go ahead and, after you've written your equation, go ahead and solve it yourself, so that you know, for one, it has a solution, and for two, you can check their work or help them with it. And try to kind of challenge yourself a little bit. I don't want everyone walking in with 2x plus 5 equals 10. Okay, that'd be pretty boring. So let's try not to all make a very simple two-step equation. Maybe try putting some parentheses in there, or some variables on both sides, so that we have actually a few steps that we need to do in order to solve this. The other really big important thing, it's surprisingly hard actually to write an equation that the solution comes out to be something like x equals 5 or x equals 8. So try and challenge yourself to do something like that.